For this assignment, we will focus on minimum and maximum differentiation in order to improve our understanding of concepts related to differentiations, such as stationary points, the first and second derivative tests, and how important they are in many mathematical and scientific applications. We will also discuss how to apply these concept to solve maximum and minimum problems using appropriate formulas. Teaspoonsful, these issues is effectively solvable.
What is apply maximum and minimum problem? First, many application problem in calculus involve function to find minimum and maximum values. The process of finding maximum and minimum values is called optimization. Before we go to the deep explanation, we must know what is the definition of the differentiation. First, what is the definition of the differentiation? Definition of differentiation, the process of calculating a function fx, rate of change with the regard of the input x is called differentiation. Second, the formula for calculating the first derivative of the function is y equal to fx is dy dx, where dy represent as a very tiny change in y and dx represent an incredible thing change in x. Third, the derivative of f relative to x is a name given to this rate of variation. Second, where do we apply differentiation? First, we use in the physics and engineering. Second, in economics. Third, in medicine. And fourth, in computer science. Why we need to understand the differentiation? First, we need to increase understanding about application of differentiation first. Second, to understand apply maximum and minimum apply. And third, to able to solve the equation by using the suitable formula in this equation. Second, how to solve apply maximum and minimum problem. First, we need to identify all the given quantitative and determine it. Second, define the variable. Third, determine the restriction of the variable. Fourth, find the secondary equation and relate to the R. Next, write the primary function for the quantitative that is to minimize and maximize. Next, use the primary and secondary equation to create a function. Next, equal the derivative of the function of to 0. And lastly, solve the equation to find critical point and relative maximum and minimum.
For the problem statement, a closed cylindrical container of radius rcm and height hcm is to be made to hold 600 cm3 of liquid. Shown that the surface area of the container is 2r² plus 1200 over r. A. Find the values of the r that minimize the total surface area of the container. Give your answer correct to 2 decimal places. B. Hence, find the minimum surface area of the container. So we know that the area is 2 pi r square plus 1200 over r, which can be written as 2 pi r square plus 1200 r negative 1. Next, we need to find the derivative of the area. So, dA over dr equal to 4 pi r minus 1200 r negative 2, and also can be written as 4 pi r minus 1200 over r square. So in order to get the value of r, we need to let dA over dr equal to the 0. So 4 pi r minus 1200 over r square equal to 0. Then 4 pi r equal to 1200 over r square. Then we need to move the r to the left side. So 4 pi r cube equal to 1200. Then r equal to cube root 1200 over 4 pi. So the value of r is 4.57 cm. For the last step, we need to do the second derivative to find the minimum value. d square a over dr square equal to 4 pi plus 2400 over r cube. Then substitute the value of r, which is 4.57, to the equation. So d square a over dr square equal to 4 pi plus 2400 over 4.57 to power of 3. So the value is 337.71. So we all know that 37.71 is greater than 0. So the value of r equal to 4.57 cm is the minimum value.
For question B, we need to find the minimum surface area of the container. First, we need to use the formula given from the question to find the minimum surface area. The formula is A equal to 2 pi r square plus 1200 over r. In this case, we are required to find the minimum surface area. Thus, the formula will change into A minimum equal to 2 pi r square plus 1200 over r. In order to find the minimum surface area, we need to use the r value that we get from question A. From question A, we know that the r value is equal to 4.57. Then we need to substitute this r value into the formula. We need to rewrite the formula first. A minimum equal to 2 pi r square plus 1200 over r. Then we substitute the r value. 2 pi 4.57 square plus 1200 over 4.57. When we calculate this, we get that the minimum value for the surface area of the container is 393.81 cm square. For question B, we need to find the minimum surface area of the container. First, we need to use the formula given from the.
To summarize, maximum and minimum differentiation require locating a location where our function achieve integrated and lower values, respectively. Using calculus technique, the approach begins with identifying key point by computing the function first derivative and setting it to the 0 to solve for x.